Hello everyone. I welcome you to the first session on atomic structure. In this session, we are going to learn about Bohr's atomic model and its limitations. An atom is the smallest unit of matter that has all the properties of an element. So we can call these atoms as the building blocks of element. The concept of atoms has been given by the ancient Indian and Greek philosophers. The ancient Indian sage by name Kanada called atom as Paramanu, the ultimate particle of matter. The word atom has been derived from the Greek word atomio, which means uncuttable or non-divisible. But later it was established that the atoms can be further divided into subatomic particles, namely electrons, protons, and neutrons. One question may arise in your mind that why we need to study the structure of atom. The answer is that everything is made of atoms. If we understand the atomic structure, we can understand the property of matter so that we can manipulate its properties and make use of them for the development of science and technology. Various atomic models were proposed to explain the arrangement and distribution of the fundamental particles within an atom. These are the few models. These models help us to visualize the interior of atoms and thereby predicting the properties of matter. Coming to the first one, Thompsons Model of atom. This is also known as plum pudding model. According to this model, an atom is made out of a sphere of positive charges with negatively charged electrons embedded in it, like plums in the pudding. And in an atom, both positive charges and negative charges are equal. Hence, it is electrically neutral. The major limitation of this model was that it could not explain the experimental results of alpha ray scattering experiment carried out by Rutherford and team. Then came the Rutherfords nuclear model of atom. According to this model, most of the mass of atom is concentrated in the center. This small, dense and positively charged core is called nucleus. Electrons are located outside the nucleus and they revolve around the nucleus in closed orbits. But this model also has certain limitations. Those are, it could not account for the stability of atom and it does not explain the distribution of electrons around the nucleus and energies of these electrons. And one more is, it was not able to explain the origin of atomic spectra. To overcome these drawbacks, Niels Bohr proposed an atomic model, which is an improvisation of Rutherford's model by combining Planck's quantum theory. Let us understand the postulates of Bohr's atomic model one by one. Firstly, the electrons in an atom revolve around the nucleus only in certain selected circular orbits. The energy of an electron remains constant in a particular orbit. These orbits are known as energy levels or energy shells. These orbits can be represented like this. See here, the first energy level is designated as K shell, second one as L shell, third one as M shell, and so on. The energy associated with the energy level increases with the increase of the distance from the nucleus. The next one, as long as the electron is associated with a particular amount of energy, it continues to stay in the same orbit. That's why these orbits are also known as stationary states. The next postulate is the energy of an electron cannot change continuously because the energy is quantized. When energy is supplied, an electron absorbs energy and gets excited from its ground state to higher energy levels. The excited state being unstable, the electron returns to the ground state by emitting the absorbed energy in the form of electromagnetic radiation. When an electron absorbs energy, it moves from lower orbit to higher orbit like this. The absorbed energy is equal to the difference between those two energy states and is equal to h nu, where nu is the frequency of radiation absorbed by the electron. Similarly, when an electron falls down from the higher energy level to lower energy level, it emits the energy in the form of photon, and the energy thus released appears as a spectral line in the emission spectrum. The next postulate is the angular momentum of an electron moving around the nucleus is quantized, which means electron can move only in that orbit in which the angular momentum of the revolving electron is an integral multiple of h by 2 pi. That is, mvr is equal to nh by 2 pi, where m is the mass of electron, v is linear velocity of electron, r is the radius of the orbit, n is any integer, and it denotes the number of the orbit in which the electron is revolving, and h is Planck's constant. Though Bohr's theory could explain the structure of atom fairly well, it also had certain limitations. Those limitations are: it could not explain the origin of the spectra given by multi-electron systems, that is, the systems with more than one electron. It only explains the origin of the spectrum given by one electron species like hydrogen atom, singly ionized helium atom, doubly ionized lithium, triply ionized beryllium, etc. The next one, it could not explain Zeeman effect and Stark effect. What is this Zeeman and Stark effect? When an excited atom which gives a line emission spectrum is placed in magnetic field, its spectral lines are further split up into number of closely spaced lines. This is called Zeeman effect. Similar splitting of spectral lines is observed when the excited atom is placed in an electric field. This is called Stark effect. Bohr's theory could not explain these effects. The next one, it fails to explain the fine structure of spectral lines. What is this fine structure? When a certain single line in the spectrum is observed with the help of powerful microscope, it is found to split into a number of closely spaced lines. This spectrum consisting of closely spaced lines is called fine structure. Bohr's theory could not account for this. And one more limitation is the uncertainty principle goes against Bohr's theory, which means Bohr proposed the existence of definite orbit, but Heisenberg ruled out the concept of definite orbit for an electron. According to Heisenberg, it is not possible to find out the position and momentum of electron simultaneously and precisely. These are the few limitations of Bohr's theory. With this, I will end this session. In the next session, let us learn about dual behavior of matter, de Broglie equation, and Heisenberg uncertainty principle. Thank you.